Okay. Hey everyone, thank you for joining the call. Um, so just a reminder, just join our Slack to get updates and make sure you register for Taikai to submit your project.
Yeah,
Uh,
just another reminder that all project submissions or project submission, or the deadline for project submission is tomorrow at 9 a.m. Pacific Standard Time. So please keep that in mind.
okay. Now, Roland, if you're ready, you can start.
Absolutely. Um, First, so my talk will be the greater responsibility of great AI power. And I wanted to start off with first thanking you guys for coming. I know this is the fourth day of the hackathon time. You must be starting to really feel the deadline coming tomorrow. And so I realized that it's a lot for you guys to take an hour out of what precious little time remains to come and show up to this talk. So thank you so much for that. And I hope you're having a wonderful time, that you've maybe made some lifelong friends or had some experiences that'll stick with you for a lifetime. And then the second thing that I'd start off with is just to thank the organizers of BitHacks for putting this wonderful event together. With particular thanks to Pranav. It's quite impressive what you're doing, and it's really wonderful to see a hackathon organized by high school students focusing on AI for social impact. So I'm Roland Maio. I'm going to my third year of Ph.D. studies at Columbia University, and the focus of this hackathon is near and dear to my heart because my overarching career goal is to try and harness technology for the benefit of society, and that kind of the way that I've been sort of zeroing in on doing that has been thinking about the interactions between AI and society. I would like this, especially since we have relatively few people, I would like for this talk to be as interactive as possible. So please, if you have a question, go ahead and chime in if you're so bold, or raise your hand. Pranav, please, if I'm missing anyone or anything, please do let me know. All right, so this talk will be organized into three pieces, into three parts. The first, we'll think a little bit more about the complexities of building AI for social good applications. After that, the second part, I'll give a little intro to fair machine learning. It's one of the areas that I focus on, and it's one of the research areas that's addressing some of the complexities that we'll think about from the first part. And then the third part of this talk will be when I'm bold and feeling confident, I'll call it how to theory. And when I'm feeling less confident, it's really just how I theory. And also what I'll do is I'll talk about a recent research project that's purely machine learning theory. And my goal is to kind of demystify some of machine learning theory, kind of demystify some of the research process, with the hopes that that you can, if you're interested in research, that might pique your curiosity and you might want to go and learn more, or tackle problems that you might not otherwise feel as confident to do now. But even if you don't go into like research or theoretical research, I think a key issue with AI for social good applications is a need for practitioners to be able to better engage with the theory. And hopefully this will start to give you some tools to do that. All right. Okay, AI for social good. Three themes I want to touch on in this part. The first is data are biased. AI is not plug and play, and AI cannot solve everything. All right, so I'm going to warn everybody that right now I'm going to talk a little bit about police brutality. It's a heavy topic, so if that's too heavy for you, please mute me now, and I will put a message in the chat when I'm done talking about police brutality. And I'll wait just a few seconds for people to mute me or turn off their sound before I get started. Okay, so data are biased, right? That's probably not news to anybody here, especially if you're the crowd that's interested in AI and machine learning. But I put it front and center because bias in data is one of the most critical issues when you're thinking about AI. And notice that I didn't qualify that statement. I didn't say data are sometimes, can be biased, or that they're sometimes biased or often biased. Data are biased. And fundamentally, one way to see why this is absolutely true is because at the end of the day, somebody has the power, somebody is making the decisions about what goes into your data. What is the structure of your data? And the people, and then you also have people who have who are doing the measurement of the data, and they get to decide exactly how the information is presented. And I think the most recent sort of powerful and poignant example of this has to do with the events surrounding the killing of George Floyd. So here is the initial Minneapolis Police Department statement on the incident in which George Floyd was killed. This was released early Tuesday morning. George Floyd was killed Monday night. And while I'm going to step through a couple of pieces in this, and as I do so, I want you to think about how this data would be analyzed by an AI. Like, what would an AI do with this data? So the first piece of this statement that's real is the subject line. It says, "Man dies after medical incident during police interaction." That is, what's problematic with that from an AI perspective? Well, this encompasses almost any possible incident in which the police are even tangentially involved and somebody dies, right? So it could be something as benign and innocent as a police officer was helping an elderly person into their car, and as they were getting into their car, the elderly person has a heart attack and passes away from that heart attack. This subject line captures that. It also captures the police pulling Rayshard Brooks out of a Wendy's fast food line, getting into a physical altercation with him, and then chasing him down and shooting him dead. And of course, it encompasses Derek Chauvin kneeing George Floyd's neck and killing him. The second thing is, so if you look at sort of a little bit more of the description, it says 2 officers arrived and located the suspect, a male believed to be in his 40s, in his car. He was ordered to step from his car. After he got out, he physically resisted officers. Officers were able to get the suspect into handcuffs and noted he appeared to be suffering medical distress. Officers called for an ambulance. He was transported to Hennepin County Medical Center by ambulance, where he died a short time later. So what's problematic about this, right? Well, notice that it's incredibly vague and broad, just like the subject line. And the only concrete description attributing any actions to any person in this description is he physically resisted officers, attributing an antagonistic physical action to George Floyd. And so this misinformation or this statement, it was so egregious that even journalists have even tried to hold the department to account for purposefully disseminating this misinformation. So from an AI perspective, imagine what you were like if you're building, for example, you're working for internal affairs at a police department, and you're trying to build an AI that's going over these past police statements, and it's trying to flag incidents that may warrant further scrutiny. Statements like these make it impossible for an AI to discern that. All right, so data are biased. The next thing is AI is not plug and play, right? As computer scientists, as software engineers, as technically minded people, we like to build our systems in a way that they're modularized and responsibilities are compartmentalized. Right? We do this because it makes it easier to build the systems, to diagnose problems, to fix problems, to upgrade problems. But when you start talking about trying to apply AI to social problems, we're no longer talking about purely computational systems. We're talking about socio-technical systems. And so the first thing is that AI systems embody assumptions and value judgments. So what you see here is an AI. This is a risk assessment that is used by 40 jurisdictions in order to evaluate the risk of a defendant of committing new criminal activity, right? And it's very straightforward, right? It's these 7 questions. And what you do is you go through these 7 questions. Each of them is a yes or no question, except for the prior violent, except for a couple. But you answer the question about the defendant. Each answer gives you points. You add up all the points. That's your risk score. And higher risk scores correspond to higher risk. So here's my first question for you guys, and please drop your answers into the chat. What are the assumptions that are going into this AI? Anybody? All right. Well, so one way to think about the assumptions is, and if you have a response, go ahead and still drop it in the chat, or go ahead and jump in and chime in. But one of the things about these assumptions are these are the only factors that are assumed to matter. Nothing else does, according to this AI. It doesn't matter if you are a parent, a single parent, or you're the caretaker of your elderly parents. That's just not factored into this, right? And what are the value judgments? Well, the value judgments are, for example, please also put your answers about what the value judgments are in the chat, or jump into if you would. Right, that it's okay on the basis of age to to assign people different risk scores. It's okay to take people and just bucket them into 2 groups on the basis of how old they are for this current arrest, right? 23 or older, 22 or younger, and to treat those 2 different age groups differently, right? So AI systems embody assumptions and value judgments. Right. Another reason why AI is not plug and play is because AI redistributes power, right? So so for most of this talk, when I talk about AI, I'm kind of synonymously using it with machine learning. But of course, AI is more than just machine learning. AI is, right, agents with some amount of agency to make decisions. And so one of my favorite examples has to do with personal assistance. So Amazon's Alexa, their personal assistant, you can now place, or as I'm sure you're all probably aware, place orders and actually complete your orders through Amazon with just a voice command. Alexa, order me something. Alexa, check out my cart. Does anybody see how this might redistribute power? And so again, just drop it in the chat if you have a response, or go ahead and chime in. Oh yes, I'm sorry, I thought that I would hear the chat chime, but I didn't. So I see, Pranav, that you answered the amount of points given to each. Yes, right. Yes, it says that that's another way in which there are value judgments being made with the public safety assessment AI that we saw. But so back to Alexa. How does Alexa choose which seller to buy from, right? By giving the voice command, you have now delegated to Alexa, and really you've delegated to Amazon, the ability to decide which seller gets your business. And so you've basically given, so that basically assigns a lot of power to Amazon to pick and choose the winners in its marketplace, right? And the next reason why AI is just not plug and play is that it doesn't necessarily change the system, right? So here is, so in 2011, the state of Kentucky passed a law that mandated judges consider risk assessments in their pretrial decision makings. And significantly, not only did they mandate those the consideration of the risk assessments, but they also required that, or they also set presumptive default decisions on the basis of those risk assessments. Now, they didn't override judicial discretion. Like at the end of the day, the judges still had the ability to make the final call. But this graph here that you see on the left, right, these lines, particularly the one on the bottom, is the low risk category. You can see the dashed horizontal line. This is when the legislation was passed. So you see an uptick in the non-financial release rate corresponding to judges anticipating when the law would go into effect. And then the solid vertical line, that's the date when the law went into effect, when now it was required that judges abide by this. And interestingly, you see a discontinuous jump, but for the low risk offenders, you see that over time, the non-financial release rate they crept back down to similar levels as it was even before the law was instrumented, the law was passed, right? So this is, really suggestive evidence that actually, what happened was judges took over time, judges went back, even with the benefit of an AI or even being required to use an AI to make their decisions, judges kind of went back to their old sentencing decisions. All right. So the next theme is AI cannot solve everything, right? And so kind of continuing with risk assessments in the criminal justice system, here's a study that came out a couple of years ago where they said, okay, well, these risk assessments are being used to make decisions. Are they really better than human? Are they really more accurate than human beings? And so they went and they took the decisions made by one of these commercially available risk assessments, Compass, and they compared it against mechanical Turkers. They gave to the mechanical Turker. They took the criminal justice records for Compass, and they gave the mechanical Turkers a brief description of each defendant, asked them to predict if they would recidivate or not, and then they compared their accuracies. And so actually, I'd like to know, what do you guys think? How accurate, so you should now see a poll and please respond with how accurate you think humans were and how accurate do you think Compass was? I know that may be sort of out of nowhere question that you weren't thinking about at all today, but just, oh no. But just, if you were to guess, you might have seen how accurate the human beings were. So if you saw that, then just put in for how accurate you think Compass was.
I don't think the poll is launched.
It's not. Oh no, you're right. I'm sorry. Relaunching. Okay. Do you guys see it now?
I can relaunch it real quick.
I just relaunched it. Are people? Okay. Yes, I see a couple of people are responding. All right, we're getting there. We've got 6 people responded. Don't worry, like you're not being evaluated on this. I think it's just going to be interesting for all of us to see what we think, or what our initial thoughts would be. All right, 4 more people. 4 more people. Do you guys need a couple more seconds? All right. All right. I'll give it another 17 seconds so that it's 1 minute that the poll is up. But in the meantime, what's wonderful about this work too is the co-authors, Julia Dressel, when she did this work at Dartmouth with Hani Farid, she was actually an undergrad. So if you're interested in doing research, talk to your professors and get into it. All right, so let's take a look at the poll results. Are you guys seeing the poll results?
Yes.
Excellent. All right, so what they found was that the human beings were about 62.1% accurate. And so quite fun. It looks like you guys are a real version of the wisdom of the crowd. It looks like on average, that's about what you guys expected. But for Compass, we have a much more interesting bimodal distribution where you had some people who seem to have been skeptical and some people who seem to think Compass would be significant, would be very accurate. And the answer is they found that Compass was 65.2% accurate. So about comparable. And when you do statistical tests, that difference there basically becomes insignificant. All right. So we spent a lot of time on that, so I'm gonna skip this one. All right. Another reason why AI cannot solve everything is, here's a question. Can good prediction be bad? Like, how could that possibly be? So imagine that we lived in a utopia. And let's think about social mobility in a utopia. One sort of way that we might think about the social mobility in an ideal world is that people would be able to rise, people would not be stuck in the socioeconomic status of the family into which they were born, right? So in some sense, this is actually fundamentally an unpredictability condition. It says, even if I tell you what somebody's socioeconomic status was of the family they were born into, that shouldn't be able to tell you anything about what final status they attain in life. All right, so we've talked a lot about the complexity of AI for social good applications, and now we'll move a little bit into a brief introduction to fair machine learning. Right. Okay. So I think the fair machine learning is actually a relatively recent field, and I think it's interesting to ponder for a moment, like why that might be. And I think part of that answer is we just weren't there yet. Like 50 years ago, or even just imagine, right? It was only the 1990s that IBM built Deep Blue and were able to beat Gary Kasparov in chess. And so I think like we just weren't applying machine learning widely enough that these problems were surfaced. But they've started to surface. So there are many, many examples of discrimination machine learning systems. I usually show computer vision examples because those are sort of the most visceral. So here we have in 2015, in photo tagging, Google's Photos tagged a couple of Black teenagers as gorillas. And then in 2018, these two researchers, Tinit Gabru and Joy Bolawini, they noticed that now you have these commercially available computer vision systems from Microsoft, Facebook++, IBM, and they asked the question, how well do these commercially available systems perform in classifying people's gender? And what they found was in all of them, you see a large gap between light-skinned males and dark-skinned females, with the largest gap being IBM, where it was 99.7% accurate on lighter skin in predicting that lighter skinned males were male, but it was only 65.3% accurate in predicting that darker skinned females were female. Okay. Also from 2018, right, the ACLU then took Amazon's recognition, facial recognition service, and they matched all pictures of members of Congress against mugshots in a database. And they found that it falsely matched 28 members of Congress. Right. And then more recently, just a few days ago, we have an example of sort of image reconstruction, where a computer vision system was built to take as input a blurred image and to try and reconstruct the underlying image that was blurred. And you see the original is, of course, President Obama. And on the right, you see that this system has basically turned President Obama into a white man. And lest we worry that, unless we think that some of these examples are relatively harmless, also from a few days ago, we have the first documented case of a false arrest made on the basis of a false positive of a facial recognition system. And problematically, notably, the person was a Black man. All right, so the examples that I presented so far, actually, in all of these examples, one common response is that the bias is in the imbalance in your data set. And that if you just addressed imbalance in your data set, that would fix the problem. And it certainly is true that some of these issues can be addressed, at least to some extent, by balancing the data better. And I think that's also part of the reason why machine learning didn't realize that studying discrimination and fairness is its own scientific research problem. Because if you think that the problem is just your data is imbalanced, then that doesn't tell you that you should go and you should actually scrutinize your algorithms. Right. But it's actually more than just biased data. So COMPAS, that risk assessment instrument that we talked about before, in 2016, ProPublica, an investigative news journalism organization, they went and they actually audited COMPAS's performance when used in Broward County in Florida. And so here's a very suggestive example where this COMPAS had scored Mr. Vernon Prater here low risk with a score of 3. COMPAS scores on a scale of 1 to 10. And Ms. Brisha Borden here as high risk as a score of 8. Now, of course, I've just shown you their mugshots and the risk scores. That doesn't mean that much. But if you look at their priors, Mr. Prater had 2 armed robberies and 1 attempted robbery, whereas Ms. Borden had 4 juvenile misdemeanors. Now, I'm not a criminologist, so I'm not an expert, but intuitively, that strikes me as bizarre. Right, and so ProPublica went and they did a more thorough analysis, and they asked, okay, well, is COMPAS equally calibrated? Meaning, does a risk score of 8 mean the same thing between a black defendant and a white defendant? And they found yes, COMPAS was equally calibrated. But another thing you might ask for your system to be fair in terms of is in terms of the false positive rate. So the false positive rate being if you were a defendant and you would ultimately not recidivate, what was the chance that you would be incorrectly classified as a high risk defendant? And for white defendants, this false positive rate was 23%. But for black defendants, this false positive rate was 45%, almost twice as much. And so building on this, 2 computer scientists and an economist set out to study this, and they asked, well, for calibration, for equal false positives, and for a kind of counterpart to equal false positives, right? Equal false negatives, right? Asking if you are a defendant who would go on to recidivate, would you be, what's the chance that you were incorrectly flagged as low risk? And they asked the very natural question, right? Because it's natural to think, look, we want to be fair. Every notion of fairness, how about we just satisfy them all? And they asked the natural question, can a classifier satisfy all 3 of these definitions of fairness? And what they found was that unless you had 2 conditions, unless either your classifier was perfect, which is not happening, or the base rate was the same between your 2 groups, that this was impossible, that you could not simultaneously satisfy all 3 definitions of fairness. All right, so hopefully that's sufficiently motivated the need for fair machine learning. So as computer scientists, right, once we realize that we need to study something in our algorithms, the next thing we need to do is we need to formalize it. We need to make precise definitions so that we can actually try to study them in our algorithms. And as you've seen 3 already, and there are actually many, many, many more possible definitions of fairness. Broadly, they fall into 2 dominant classes, notions of group fairness and notions of individual fairness. And it's an open question, like if there's a universal definition. I think like in the beginning of the field, there was a lot of work in this area. Or I think there were people who maybe tried to do this, but I think the consensus is evolving to there is no universal definition. Kind of like what we were talking about with AI not being plug and play. Really the right notion of fairness is context dependent. And it's always good to keep in the back of your mind, can fairness even be formalized? All right, so demographic parity is one notion of group fairness, and we'll see this again. So the intuition with demographic parity is that a machine learning predictor should assign the same outcomes to each group. And I put same in quotes to mean insert formal definition here. All right, so the formal setup for group fairness and for defining demographic parity, which you see here in the sidebar, you have individuals, and they're represented by triples, X, Y, and A, where X is a feature vector, right? This is some information you have about them, their age group, their priors. You have Y as a target variable, right? This is what you're trying to predict. And you have a group membership variable, A. And so, right, and then we're considering a binary classifier and a set of groups. The classifier doesn't need to be binary, and you can generalize the definition to other predictors. But for the definition I'll give you here, we're going to just consider a binary classifier, right? So binary classifier C for a set of groups G is said to satisfy demographic parity if for every two groups G and G prime from the group set of groups, it holds that the probability that an individual of group G is assigned the outcome 1, that this be the same as the probability that an individual of group G prime be assigned the outcome 1. So intuitively, this would be to say, if you're hiring applicants and your pool consists of half women and half men, that if you hire 10% of the men, you should also be hiring 10% of the women. All right, and then in individual fairness, the intuition is similar individuals should be treated similarly, right? And so I have two similars in double quotes for two pieces of two formal definitions that need to be plugged in there. So the formal setup is individuals are represented by two tuples, X and Y. So notice we've gotten rid of the group membership variable that's taken up in the setting of group fairness. Again, X is again a feature vector, and Y is again a target variable, what you're trying to predict. In individual fairness, usually randomized predictors are considered. And so we'll consider a randomized binary classifier. And what is randomized just means that instead of the classifier taking X and always saying it's 1 or a 0 for every time it's given that X, sometimes it might say 1, other times it might say 0. Right. So now to formalize this notion of similar individuals, individual fairness requires sort of a task-specific similarity metric, little d. And this is supposed to tell us just how similar these two people are. And to try and formalize this idea of like, what is similar treatment? Well, how are they being treated? The treatments are the outcomes of the randomized binary classifier. So individual fairness also has a distance metric, big D, which is over probability distributions. And so individual fairness says, formally is a randomized binary classifier C is said to satisfy individual fairness if for every pair of individuals X and X prime, it holds that the distance between the outcomes the classifier assigns those two individuals, that this be no more than how different these two people are according to the task-specific similarity metric. Now, you might be wondering, well, why do we need these two different notions of fairness, right? Like, and I think individual fairness is, in some sense, a really nice, intuitive definition that, in some sense, nobody can really have. In some sense, it's hard to have a problem with individual fairness. But the issue is that in order to apply it, you need this task-specific similarity metric, little d, right? So if you're thinking about hiring job candidates, little d should be something like, how qualified are these two people for this job, right? And clearly there is no magical oracle in the sky that we can query to be able to say, hey, look, these two people, how qualified are they, right? Um, there's actually a really interesting line of work where they're trying to figure out, how do you learn this similarity metric over people using by asking kind of human arbiters, asking humans for their judgment. All right. Okay.
Hey, Roland, I just
Yes.
had a quick question regarding individual fairness.
Please go ahead.
Yeah, so for the intuition, it says that similar individuals should be treated similarly. So is that based on like a variety of factors? Because based on the previous examples that you gave regarding, I guess, like like prison rates or conviction rates, or not necessarily rates, but that type of um, field, uh, couldn't it become biased if factors such as race or gender were put into play, because it says that similar individuals should be treated similarly? So could that potentially become a problem?
Absolutely, for many kinds of reasons, right? That you've touched on directly. So I think like one example that comes to mind in the context of risk assessment is the state of Wisconsin. They noticed that actually when they used the same risk assessment for men and women, that was extremely biased against women. That is right, like uh, the a woman or a man having the same sort of like informational profile, and so like being assigned the same risk score by the risk assessment instrument that they're using, that actually that wasn't well calibrated. That was really badly calibrated. So if you're taking the similarity metric to be like if you're thinking that, oh, if they have the same sort of information that you're using, and that means that they're exactly similar, then you would actually be really unfair to the women. And in fact, Wisconsin now uses two different risk assessment instruments, one for men and one for women, because this disparity was so extreme. Did that answer your question?
Yes, yeah, it makes more sense then.
Awesome. And actually, I think I'm running a little bit low on time, so this might be a good time to. I'm not sure that I have enough to do the last part, so this might be a good place to pause and see if anybody else has any questions about what we've talked about so far.
I just had one clarification or like a question.
Sure.
So, so how have softwares like Compass like advanced over like the time period from when it was first used, and then how often are they used to determine?
Yeah, that's a great question. Okay, so Compass or so there are a variety of risk assessments that are used in different jurisdictions across the United States. I would presume that this is the same picture worldwide, but I don't know for sure, so I won't say that for sure. I'm just for the United States. Um, and if you trace the history of risk assessments in the criminal justice system, it actually goes all the way back to the 1920s. And it's like, I think it was the very first paper on like, let's try to use statistics to predict how risky an individual is. I think it's from like 1921. And in many ways, the many of these risk assessments, they still use the same kinds of techniques, right? Like, if remember the public safety assessment that we looked at earlier, right? That's basically just your typical statistical actuarial technique. You look at the features, you assign scores based on those features, and that's your output. Interpret it how you may. And so in some sense, right, like I actually I think that this is actually indicative of another fundamental limit in sort of prediction for AIs. Like I think in terms of what information you could possibly use that is actually predictive of recidivism, it basically boils down to those few things, right? What's their age group? What's their gender? What is their criminal record look like? How many priors do they have? Now, in terms of how it's used across the United States, It's applied in many different ways. So some jurisdictions, the judges have access, have discretional access to risk assessments, so they can consult them if they would like. Others are a little bit more strict in terms of requiring their judges to take them into account, like we saw with Kentucky. And others still, for example, in fact, California recently passed a law where they basically delegated all of the decision making to risk assessments. Their law mandated that, I think it's like at the county level, counties develop their own risk assessment instruments, and on the basis of the output of those risk assessment instruments and nothing else, kind of pretrial bail decisions would be made. Okay. Any other questions? Okay.
I think someone is typing in the chat. Or
oh, yes.
someone to ask a question.
Yes, I can share some resources for understanding risk assessments and how that applies to fairness in machine learning. Did anybody else have any questions? Before?
Yeah, sure. I had a question. So what's the timeline to creating a more fair AI? Like, do you see it improving incrementally, or just all of a sudden we see a jump and we have the fair AI?
Yeah, that's a great question. So I think, right, like, it's going to be application and context dependent. So, right, when it comes to people talking about AI, there's one school of thought that thinks, we're going to build some sort of like sentient artificial intelligence that is somehow smarter than us, and that will, overtake us or something. And you might think, and I think it's natural to kind of think, well, maybe that AI could be more fair than us too. Am I mischaracterizing your question, or am I understanding you?
No, that's perfectly right.
Okay, good. So I don't want to misrepresent anybody. So when it comes to the general AI debate, I'm in the camp that says I don't think that we're like, I'm skeptical it's even possible to begin with. And second, I don't think that it's realistically going to happen anytime soon. I'd say in the next 100 years. I feel confident saying that. But you bring up an interesting point about like sort of how quickly will it happen? Like, will it be a sort of threshold kind of function where we don't have general AI, and then the next day we have general AI, kind of like, and that's an interesting thought, especially because if you look at deep learning, in some sense, the progress in deep learning in computer vision and now natural language processing kind of saw that sort of discontinuous threshold jump, right, where it was sort of flat and incremental progress was being made all the way from the 1960s until 2012. But then in 2012, like all the pieces came together. We had good algorithms. We had fast hardware to compute. And suddenly we just made this discontinuous threshold leap in performance with deep learning on a lot of these tasks. But when it comes, and I think that something similar could happen with like a general AI or a fair AI, where it's like, one day things just aren't working, and then the next day, like all the right pieces of the puzzle come together, and boom, we have artificial general intelligence. But again, I'm skeptical personally that AGI is feasible. But going back to the first part of your question about how to make fair AIs, I think that the answer is we can have fair AIs today, but it's not about the AI being fair, right? It's all about the socio-technical system that you're thinking about, right? So I think, you know, when it comes to the criminal justice system, it has a lot of problems that aren't really artificial intelligence problems, right? And you know, it conceivably, to make it more fair, would require a sort of restructuring, or rather, if you apply AI in a system that's already unfair and unjust, that's not really going to make it unfair. But if you restructured that system, then there might be a way for AI to be incorporated such that it could be more fair. And that, I think, doesn't, like, with the tools that we have now, that could be done tomorrow. But the challenge, I think, more often is one of sort of a political challenge and an institutional challenge. Did that answer your question?
Yeah, sort of. So let's say that, like, as a software developer, what concrete steps can one do to get to the fair AI tomorrow?
Right. That's a great. Okay, so that's an awesome question. So what I would say is, you know, immerse, like, learn more about what it is, you know, like how the AI is being applied, and learn about the context in which it's being applied. And then, you know, and grapple with these issues, right? So, for example, there was one researcher in computer vision. He actually stopped working in computer vision because he saw the direction in which the field was moving, right, towards law enforcement applications, uh, military applications, and he personally objected to those. And so he thought, you know, so he decided not to be engaged with it, right? That is, you know, like, you raised $1 million question. I think, like, we can do a better job, or I think, like, one of the important things to do is to try and come up with more concrete answers to your question, right? Because, like, I would love to hand you a checklist of, like, here are the things you need to do to make sure that your AI is fair. And you could just take that, and being a conscientious and earnest software engineer, you know, just make sure that you check those boxes, and boom, it's fair. But I think that's that, like, and I think we can come up with some checklists like that, but that won't be the full answer. There is also there was also some recent, actually, there is some work in that direction. If you look up data sheets for data sets, that'll pop up a paper where they propose, like, kind of better ways of documenting your data sets to be fair.
Great, thank you so much.
Yeah. Yeah. So let me. All right. I think we definitely don't have time for the last part, but let me zoom here, and so we can just continue the Q&A. And I have a question for you guys. You know, what is the greater responsibility? And if you would go ahead and drop that in the chat, and ask questions at the same time, I would really appreciate that. So, any questions?
So I don't want to be the guy that takes up too much time, but it seems like a lot of issues these days are caused by new emerging technologies, and how these large governments and companies are more interested in profit than ethics. So it just, some days I wake up and I think, you know, the humanity is doomed. But I mean, I laugh about it, but, like, as an undergraduate researcher, like, what can I do?
So, you know, I think there are many ways in which the picture is very bleak, or the pictures are very bleak, and, you know, that's real. and that is heavy to think about. But what I would say as an undergraduate researcher is try to, you know, synthesize your scientific, or or maybe you're not in the STEM fields. Maybe you're focusing on something else. And I think there's those the other fields are just as important. Um, uh, Try to find a way to synthesize meaningfully addressing one of the problems that you care about with your research interests, right? So that's like, I find artificial intelligence fascinating, but I worry that a lot of the AI pipeline is really corporately oriented, or oriented towards applications with which I disagree. And in some ways, as a researcher, that can actually make your life easier, because it means that everything else is being ignored. All the other problems aren't receiving as much attention as they can. So try to find a way to, whatever your research interests are, follow those research interests and think about how they can be applied to problems that you care about. And and I would encourage you to dig deeply into those problems as well, to maybe try and find one that you feel like you can make some kind of difference. You might not be able to solve everything, but I think trying to address maybe one small piece of the puzzle as best you can is a meaningful, impactful thing for an undergraduate researcher to do.
So I had one question, not necessarily about the greater responsibility of AI, but more about why you wanted to do a PhD and pursue this topic, or like this field.
Well, I think it touches a lot on what Ethan was asking, where I was like, I was really amazed by AI as an undergrad, just blown away by its potential. And so early in my undergrad, I was like, I'm going to go do research in AI. And then as I progressed in my undergraduate career, a lot of these problems with discrimination and unfairness in machine learning started to surface. And so I thought, like, I love AI. I want to do something impactful, or try to address some problem in society. And so here's a field that needs people to go and think about those things. And so I can do both simultaneously. And so that's why I started in fair machine learning.
Does anyone else have any questions? Okay. So thank you for speaking. It was a very good talk, and uh, yeah, it was. I'm sure a lot of people, they learn more about AI and its uses, and some of the bias that occurs. And thank you all for attending.
Yeah. Yeah, thank you so much, Pranav. But if you see on the screen, my contact, it's roland@cs.columbia.edu. If you guys would like to talk about more, just AI, research, academia, or anything, please feel free to contact me. And I'll stay here for a little bit to chat with anybody who might want to stay behind.
I had a question about the fairness.
Sure.
Like how you treat similar groups similarly. So if there's bias in, like, there could be bias in how you group those similar groups, right? Wouldn't that affect the data? So how would you eliminate that? Like, how would you?
So sorry, could you it was a little choppy at the end when you were talking about collecting data. What were you saying there?
Right, so how would you like group those similar groups? Like, on what factors would you group them to make it like as fair as possible, so that it doesn't affect the data negatively, but still.
Yeah, that's a great question. So I'm not sure if so I might be this might be a little bit of a little bit off from exactly what you're asking, but so I only talked about two of the broad notions of fairness, right? Group fairness and individual fairness, and I think what you're touching on, and correct me if I'm wrong, is sort of intersectionality, right? We don't just have exclusive monolithic groups. We also have people who belong to different groups simultaneously. And so there's a notion that tries to capture that called subgroup fairness, where you have a richer structure to the groups, where individuals can be annotated not just with one group, but they can be annotated with any number of groups. There's been some work on like when you're given those subgroups, how do you learn a classifier to still preserve a lot of utility? When it comes to collecting the data, you know, that's a great question. And honestly, I don't know that much about the data collection side. I think it is like, I think what you're touching on is like, if your data does not sufficiently distinguish individuals in the groups, then that might create because those groups can't be distinguished, you might then have discrimination, and that's actually a really important point that you bring up, because for example, if you think about like online applications, for Google, for example, where they have a classifier that's deployed online. The only information that they have about you for their advertisements is like your browsing history or like some information about your browser, and they have to make predictions, but they don't necessarily have access to your group, like to what group you belong into or what groups they might care about being fair to. How do you then do your best to be fair in that circumstance? There's also some work along those lines. So all is not lost, but it is a much more difficult and challenging problem that you bring up.
Okay, yeah, thank you. I think, no.
Thank you for the question.
Yeah. If anyone else has a question, you can ask it now. Otherwise, we're going to conclude the meeting.
Okay, it doesn't seem like we have any more questions. So thank you again for taking the time to speak, and thank you everyone for attending.
And thank you for inviting me, and thank you all for coming.